Hello and welcome again to Steve Longstreet Workshop, where we look at anything that be looked at anywhere else and come in various states. But I do do stuff for myself quite often as well. This is not a radio or a tape recorder or anything like that. This is a power supply, but a special one. These were quite popular with users of those vintage battery valve sets from the 60s and before, mostly the 40s. They used D series valves, usually DL90s, but occasionally DL3s came up, and also this one is adjustable, so any battery with 2-volt valves in as well, or higher HT, it can cope with this one. Something's been in here before. I know that for a fact because it's got a new cable and a new plug, and that on the side there, switch system, and a very secure way of holding it in place. That is something, that isn't it? Yeah. So this unit has been worked on by other people in the past. By the way, never put anything like this to a battery valve set unless you know that it's alright. The reason for this is quite simple. Battery valve sets use battery valves, of course, and battery valve sets, because they use those battery valves can be a problem. Be a problem because if you look at them the wrong way, they go. Look at them the right way, sometimes they go. If the day ends in a Y, they fail, etc., etc. So obviously it's something which you need to be very much aware of, otherwise you'll be here all day playing about with them and realising the valves have failed. So first of all, with this, get the top off, which might be a problem here because I think these screws are busted in, and take it from there. So what have we got here? Well, we've got a transformer, obviously. Transform 240 volts, 250 volts AC or 210 on the front here. There's a knob here for that, which goes strictly on 250 here. Down to small voltage for the valve heaters, that's the LT, and a bigger voltage for the HT, that's the anodes in that. Okay, so again, that's done here. Now, there are two separate diodes here, one for heaters and one for the LT, which are these two here. That's obviously choke, yeah. Capacitors, well, that one is for is obviously for probably HT, because this one is much higher voltage and much lower down on the scale. Only 3-volt DC this thing, but about 1,008. Is it 8,000 volts? HT, well, yeah, those two will have to be checked if not changed, obviously. The diodes on this are the old type, which might be okay, might not. Again, I don't really know on that. And so again here, another choke here, two chokes, one for HT, one for LT. LT, by the way, on battery valve sets, has to be smoothed more than HT does, a lot more. This is because battery valve sets are made to work primarily on batteries. Yeah, there are battery valve main sets out there, battery, yeah, like the Murphy and what other that I've done on this channel. I tend to run those purely on mains, but because the battery valves have so much with it. The battery valves are used to having DC. Obviously, they can't have DC straight away because this transfers it. But AC, of course, ripple current and ripple and things like that, so it has to be smooth. Basically, battery valve sets of this kind on on mains. It's like a woman in charge of something. You know, a dog on your hind legs, done but not done well. That's the way it is, you know. So yeah. So basically, these are very much they work, but you know they can be very much, you know, well, not snake oil, but you know, if not done properly, then problems will occur. So first of all, across the plug, like that. That goes onto there, like that, and we'll put it on there like that, and we should get something. There we do. And there we get something, but it's not enough to trigger it. So what's it? 200 volts, 200 ohms, and that's about 200 ohms. That's okay. 198 ohms. I think we'll live with that. So the transformer's okay on the primaries anyway. Now the secondaries, again, should read similarly. So again, we go back to that and see. Right, on the HT secondary, on the HT side of it, it's looking at 320 ohms, and on the other one with the low voltage, it's basically something like, well, very little in fact, because of course, yeah. But don't forget, that might be because the dials might be short circuit. Be very, very unlucky with these, but it can happen. Now, because these set me down so much, these go up in value a little bit, it doesn't really matter. So again, might change them, might not. I know I'm lazy. I'm terribly lazy. I know, but there we go. Now, the HT side goes through this one here, I think, and here, and the LT goes through here. I don't know, but I'll be looking. We'll find out. So that goes out of the way. By the way, I haven't got a schematic for this, but really I don't really suppose we need one. So so we ain't going to get one yet. Right, so let's a few wires up and see what goes where. Yeah. Okay. Right. The high tension is here on the front. The low tension is here through the meter. That we know. Okay. This, by the way, if you want to know, is an Amplion Convette model M2V. Okay. And I will replace parts and leave it exactly as it is, but at the moment I do feel that we've got a fair way to go before this sees mains. Well, transformer's okay. So yeah. So the next thing we do is look at the capacitors here, because of course they might be okay, of course they might not. Why is that going to ground? Why is that going to ground? Oh yeah, fair enough. Yeah. So that one. So this one must go to that. This one must go. Anyway, I'll go around with the meter and find out. Okay, so that goes onto there. This goes onto there. That's okay. So that's always this sort of stuff, always do it with your meter on ohms. Fault finding with the meter on ohms wherever possible, because you know there won't be high voltage delivering to give you a nasty nick. So wherever you can, always fault find anything like this on ohms before it gets interesting, shall we say. Okay, fine. And it goes through here. It goes, I think it goes. I might possibly take 1 or 2 bits off this just to see what's what, because I can't really tell all that well, and I want to try and get the thing right. So I think 1 or 2 things might need to come off and be looked at elsewhere. And also, by the way, it's worth doing a diagram of what's what, even with something as simple as this. But if that's full wave and that's half wave, I bet you any money that's HT and this is LT. Okay, actually it is, because that there is connected to that which is obviously LT, because it's only 3 volt DC working, whereas this one is probably a bit more, but they're both going to come back and be checked, stroke replaced. So yeah, but voltage is on that. Dear, oh dear, oh dear. 3 volts, yeah, and of course this one I'm going to put in something like 250. I think the first thing we do is have a look and a think. Always have a look and a think, without fail. So that is the okay. Yeah, that goes to there. I hope that's all right. By the way, I'm going to check that and make sure. Because if it's not, then we need to try and do another pot to go there. Again, do it on the volts, on the ohms range of the meter for safety's sake. That seems okay. And that must go. Oh yeah. So this goes to here and goes to here. Okay, I know what I'm doing. I'll just draw a diagram and get back to you. Right, here it is, the piece of balls over drawn out, and I've taken working parts out to do it actually, because some are going to have to be replaced to make this thing work. Main transformer we know is okay. It takes 2 outputs, LT and HT. The transformer was at 7.5 volts and 130 volts. Offline there'll be a bit more than that, because there won't be on low, but there you are. The HT, first of all, 1 diode, capacitor, 8 microfarads, choke, capacitor, and out here now, 3 outputs with some 35k resistors, which I'm going to check and make sure they're okay as well. If they're not, they'll come in. If they are, I'll leave them. That's just so you can set to your radio, whatever it is. Most of it's about 90 volts or thereabouts, but it does vary, so that's why that's there. HT is a bit different. That's HT. LT is a bit different. Goes to rear start there, like that, into a big rectifier here. Comes out to there to a 1000 microfarad capacitor, to a choke, to another 1000 microfarad capacitor there, and also there's a button on the front which makes the meter read what's coming at the front here to there. Now the meter on the front should not go above 2 volts. It's marked, but I will check it, of course, when it's working against something which I know is okay. It's this thing here. So that's how it works. Now, if you look at the back, in the back here now, I'll just shift that. There you are. The new capacitors will take up no more space than the old one. They're considerably less. On the AT side of it, you're not stuck to 8 to 8 microfarads at all. I think I've got 10s. They'll do. Okay, so that's okay. Now on the LT side again here, 3 volts. That's a bit low that for working voltage. So that will go up to say, I don't know, 10 when I've got the hand relay, you know, to go into there. Oh, but really that again with one of those rather than a valve rectifier, as long as it's at least that, then it'll be okay. Yeah. The meter on the front here, I'll just turn the thing around so you can see, like that. The meter on the front there, I'll just produce it better. Yeah. What that does, it doesn't actually say what voltage it is, but it's a scale. So if you press that there, then it should actually come up good or bad, as it were. So that's there. So anyway, now we've got the thing apart, and I've looked at it and got down the circuit. We've now got to get the bits, and with that capacitor, I've been naughty. Actually, I did put this on for a second to see what it would do. It seems to work, but obviously I can't leave it like this. So that capacitor and that capacitor are going to come out on this, especially this one, the valve heater. That has to be right. Yeah. Also, I think it might was putting a diode in as well, because, you know, if any of this goes wrong with the voltage sensor, we don't want it. It never ceases to amaze me that components in the size of new compared to old. That's the old smoothing cap off the AT side. That's the one off the LT side, by the way. These are replacements. I mean, if I was to put them side by side here, like that, see? Look at the difference. It's amazing, isn't it? Right, so what else have we got to do before we start fitting components? Well, first of all, assuming the diodes are okay, easy to change if they're not. The other thing which I might have trouble obtaining is, of course, the chokes. So, 2K on there, okay, and that one's okay. So 6K, in fact, it will probably do that. It will. So the one on the LT is okay. The HT one is here. So we goes from there to there, and that is about about 200 ohms. Again, will it possibly do it? Will it? It doesn't show. It doesn't make a sound, but as you can see there, it is okay. Now the other thing that bothers me with the fan, which is always check, regarding these battery valve radios, the cathode and anode section of the output valve is very different on them. And so the AST, there are two earths, okay. The one on the chassis on them, the one that goes to the heaters, is the main one. But the AT one is 300 or so lower down to create the bias for the pentose section. Okay, so we need to check this. So what we do, first of all, go on to ground here like that, Yeah, and there, that's working. Right, okay. Now, on the positive side of that, there shouldn't be anything good because, well, that's missing for one thing, but chokes are in place. So again, now go over to the AC side now. There shouldn't be anything anywhere here. This is because, and you can see there isn't. Yeah, this is because of the voltage, the HT negative voltage, which is held low. So the HT and the LT should not meet. On that diagram, actually made a mistake. I put everything arrows on them. I should have done that actually. I'll show you that again in a minute with them taken off. But now you see, on the positive side, just to check, the negative, there's nothing, okay. Coming over here again, there's nothing, and there's nothing, and this side of here, there's nothing, and that of course is the positive side through that choke here, which we fully check that's okay. Right, anyway, where is it? Here we are, this one, right. That earthing arrow and that earthing arrow should not be there. My fault, I know. So those two, just disregard them, okay? Because I'll take them out anyway, but they shouldn't be there. So this is now ready to have the capacitors fitted. And then of course, we will of course try it and see. First of all, I'll do the HT, then I'll do the LT. This is working here, by the way, and so is the across it here. A restart system here, and also the meter. There's this button here, which makes the meter read as well, and I shall also check that as well, make sure that goes right the way down if it should be doing. So now we know what we're looking at. We know any design problems are sorted. So now it's time to fit the capacitors and try it. Right, now here is the circuit of one of the radios in question, the kind that this thing operates. This is an ever ready set, but they're all the same, like I've said. And if you look at this circuit here, you see there are two HT positives and two HT negatives, as you can see there. The HT negative does not go directly to ground, as you can see there. So the two have to be separate in the circuit itself. You see, LT negative and HT negative are there. You see. Now, in this case, you see, LT negative goes to deck. Yeah, goes to deck. Yeah. HT negative goes to those resistors there. And so for that reason, they can't have the two negatives tied together in the set. You just can't do it. That's why. If we look at another model, if we have another model, I can see here. This one shows it better actually. You see here. LT negative, deck. HT negative, deck via that resistor there. Yeah. Going to there. And so LT negative is there, LT positive is there, going to these resistors which are in parallel, and HT positive is there. That is why. Okay, that is why. Now then, time to start changing components, I think. So let's get on with it. Like I said, that being replaced by those. Amazing, isn't it? Absolutely amazing. I always think so. But now we've got to work out how we're going to do it. I'm not going to put them in there. There's no point. And negative, of course, ties to here as well. Okay? So I'm going to probably go using that pin as negative and using those two as the positives. With a power supply like this, which supplies voltages to those small valves, the B7G and D series valves, you have to be careful because there are in fact two sets of those valves. First of all, capacitor to rim, and the voltage across here, that the LT unloaded, is about 9 volts. There wasn't any regulation those days, so I'm doing it the way it was done then, sort of. But at the same time, I'm making this thing put out 1.5 volts. Not as easy as it sounds. It's not easy as it sounds because there are in fact two sets of valves you can get for these sets, the DL, DK, that lot. There are in fact two sets of valves you can get. And the difference is the heater voltage. This means that the heater voltage is less on one set than the other. So exactly half actually. That means therefore that this switch here has to cover both settings. Yeah. With a radio that has the valves in series, you can't mix them, but with these bag sets with them in parallel you can. The same as in battery valve main sets, valve main sets, you know. So this will only work with the valves in series, and so there's two types. So what I've done, I've got this set of resistors here is working as the valves on the higher, that's 0.05 amps radios. Yeah, it should be 5.6 volts. It's 6, but with it on 6 volts now, it's just about 1.12 volts. That will do. That will run. That'll be okay. Yeah. Now the other lot are twice that. And again here, if we take it down there and we put these valves here in, these are ones for the bigger ones. It does that as well. So with a 47 ohms and 100 ohms in parallel, it does do it. So now I'll put those inside properly, and that's the LT done. HT isn't quite as bad as the LT for precision, shall we say. The LT's in, and so it's working. Now the HT. Now, one of the resistors on the HT side of it has gone high up in value. But when you bring it down anywhere. Now, coming from the off the transform of the capacitors here, it was 185 volts offload. That's a hell of a lot, way too much. But now, of course, with it down a bit, as it were, we can on the middle pin here, it is 67 volts, which is okay for American sets, funny enough. Well, the top one now is here. Yeah, put it all back in properly. That is now about 95 volts, which is about right. So of course, from there it goes up or down. So that is now sorted. Now the other thing with this, by the way, is the meter on the front doesn't work. You're supposed to get when you press this button here, but you don't. So that's the next thing. It's very simple. The meter itself works. I can prove that now by going to 200 ohms and going across the back of it like that. Okay, go on there then. And like that, as you can see, it reads okay. So that is okay. So all there is apart from that is a button down here and a lever. So that's the next thing we have to worry about with this this unit. It doesn't really matter the battery, but I like to have things working. So well, I just like to have things working. So we're going to. So put it on like that, and put it in, and it doesn't read at all. So out it goes like that, and I'll put a load on it and see what it does then, where the load is. I tied it up a bit while I was looking, you see, and I'll probably put the load somewhere, unfortunate, so I'll look for that and then I'll take it from there. Never, by the way, never put stuff away when you're still working on it, because it's not a very good idea. The load on this, by the way, is either 10 or 5 ohms or thereabouts. I don't know where it is. I'll come back to you. And there we are. If you look on the circuit here, there's a load on there, and the meter is there. And you press this button here, and it doesn't do anything at all. Now we know the meter's okay because I checked it with the meter. With this meter, that meter is okay. I checked it with that meter. There's no on the ohm range, but it isn't doing what it should be doing. Now all it is a contact. Put the meter in circuit. That's all. So it won't be much, but have a look and have a see, because, well, why not? If we put the thing over on the other side like that, as you see that, you see there's that there, and it's pressing that, moves that up to there, and the other end of it doesn't seem to go anywhere. It doesn't seem to go anywhere. It doesn't seem to want to go anywhere, that, but we'll see on that as well. So it goes to there. Okay, so it goes from there to there. Okay, so the problem is probably here. So I'll just it seems to be contacting okay, and there's a fault straight away. So wire come off. Simple as that. Simple as that. So wire comes back on, and then of course we should be able to read the meter. I won't be using the meter on this, but I'd like to have it working. Simple as that. A wire off underneath. It had to solder it back on, but there we are. And now we see, if I press the button, there you are. It's working again, as you can see there. Okay. 1 and 2. There you are. So it's working. So this machine now has the LT and the HT sorted to work on the I keep wanting to say modern sets, but they're not really, you know. They're so now it's a matter of putting the thing back together again, and of course putting it into action. So I'll put it back together again, and as soon as the job comes around, I'll be using it. Another tip, by the way, is these. These are from. These actually come from one of the tool shops. I forget which one off the top of my head, but what they are is a box of various sizes of rubber grommets. I think these came from one of the tool warehouses, Screwfix, something like that. And they come in various sizes, and they also come in ways that don't actually have a hole in them. So if you make one like that and put that in there like that, you see, you have straight away a cable grip. So it's another tip from the top for you there. Now with the unit together on the bench, like so, we can see that both these units. I'll put the meter back on. There you are. The LT is currently at 1.1 volts. It's adjusted by this here, so if that goes down like that, that should go down to 0.8, as you can see there on the meter. I think you can't you? No. Do that again. There we are. Right, can you see that? There you can. Okay, fine. So there, that's 0.8 volts there. I can put it back up again, and we shall see. We do it a little bit more. Okay, that's how that works. Now that's the LT. Now the XT side of it is the side which is the one which uses higher voltages, high volt fun to play with. So that goes into there. Those is, by the way, that's the low for the XT. Okay, that goes into there. That goes back up there like that, or even like that. There you go. Hold it, and off it goes. And you can see there 135 volts on there. Okay, so we go down one from there, then it'll be less, as you can see there. It should be about oh, hang on, there we go. Right, try that again. So that now goes into there like that. This now goes into here like that, and you see 95 volts, which is near as damn it as far as 90. So this unit is now ready to serve battery portable radios. There's 6 ohms there. It should be 5 or 5.6, but I don't have any suitable resistors, so I just went for 6 ohms. That's there, and these here are that's a load for the XT. So there you go. That's the two of them side by side. So now, of course, this is now working without that. By the way, the voltage will shoot up because it's not a load, as we'll see. As you'll see there. There you go. It's a lot right there. I mean, 208 volts there, you know, and here, no, with the thing not on load, it's about 9 volts, which I will demonstrate for you, sort of like now. So that goes onto there with this thing, and that goes onto the top one. So that goes onto there, and without it again, that should be a much higher voltage, which it would be if I went to the right scale on the meter. It's overloaded now, so there you are. So it's about 9-10 volts, as you can see there. So yeah. Also with this, by the way, the knob on the front here for different voltages, which in this case I can use to vary the voltage on the front slightly as well. So it is once again working, and it's modified now to operate on 90 and 1.5 volts on both ranges of valves. That's in 0.05 amps and 0.025 amp valves, or 50 and 25 milliamps respectively. But only on the sets where they are in parallel, which most of them are. The ones within series, by the way, as I said previously, they are the ones which are used for both mains and battery. Those I tend to run them on batteries. Well, there you are. That is now a power supply. This is now working now in a bit of test equipment for me to. Oh yeah, the meter. Right, the meter now. As you can see there. Hang on. it works, as you can see there. Again, offload, so it's very high. So there you are. But that meter really is very much a go and no go, because everything else we do with the meter. Valves on this starts at low, and of course bring it up gradually, and that'll be all right. But there it is. Amplion Convette. Now use a piece of test equipment for only for battery valve only radio, where the valves are in parallel, not the ones where they're in series. Okay. Also, with them being in parallel, you might come across a mixture of the two. Again, just this respectively, and keep the voltages on the heaters low, because they do tend to blow very easily, those valves. I mean, if they're white at the end of the day, they'll blow. You know, they are like that. So be ready for that. But anyway, here it is. It's a working power supply, Amplion, and it's been modified. And so for me, it's Steve's Longstay Workshop. Thank you very much for coming on board, and I'll see you soon. Take care and bye bye. And of course, keep fixing radios, tape recorders, power supplies, TVs, record players, computers, anything electronic. Why not? It's fun and it's a way to live. Bye bye.